It's time to export the knowledge. Alright, let's talk about locus of parabolas. So, let's just write down the condition. So the locus of point P, which is x comma y, such that its distance from the focus, or F, a comma 0, is equal to its distance from the directrix x equals negative a. What on earth am I talking about here? So, let's have our graph here. First off, a directrix. It said x equals negative a. So, we might as well plot that. So, let's say this is negative a here. We have a straight line going through here, and that's our directrix. This directrix is just a straight vertical line that's parallel to the y-axis, which I should probably label. Now it's saying that from the focus, a comma 0, so where's a? Let's say a is here. There's our focus. Our focus is here. So if that's our focus, it's saying that the distance between the two have to be equal. So if this is a units and that's a units away from the origin, this would be a point here, the origin. Well, I can apply the same logic by saying, well, if this is 2a, then I can bring it up and swing it around. So I now have another point that I can use. And I can bring the same logic down to where 2a is. Here. So this is a comma 2a, and this will be a comma minus 2a. If we were to solve for all points of P, we'll find that it's actually a sideways parabola, like this. So let's do the math to prove it. So referring back to our set of conditions that we made for ourselves, it's saying that the distance from P to F is going to equal from P to M. And what I mean by that is that when we have the directrix here, if this is point M, there's our point P, and here's our focus, this M will move along the directrix up and down. So this point M will have the x value negative a, because that's what the directrix is, and then the y value will be the same as the p value, just y value. In doing so keep that in mind when we actually start doing some working out. Alright, let's set up our distance equation. So the square root of, so the focus is x minus a squared plus y minus 0 squared is going to equal the square root of x plus a, because remembering the directrix is minus a, plus y minus y squared. Now we can simplify that so we're just left with x plus a, but we're going to square it anyway, so let's just do that. So now we'll have x minus a squared plus y squared. It's going to equal x plus a squared. So now if we expand it, we should get some cancelling. So x squared minus 2ax, remembering the a plus b squared equals a squared plus 2ab plus b squared, plus a squared plus y squared equals x squared plus 2ax plus a squared. We have some cancelling. The a squareds cancel, the x squareds cancel, and I'm now going to move this negative 2ax onto the other side, which gives us our form. Y squared is equal to 4ax. Here's our form. So if that's our general equation here, in general, y squared equals 4ax, our focus is going to be a comma 0, and our directrix is x equals negative a. With this in mind, let's do an example. So we have y squared equals 8x. So if 8 is equal to 4a, what is a? Divide by 4a is equal to 2. With that in mind, we can go sketch. So if a is equal to 2, I just need to find where 2 is. There's 2 there. And then my directrix will be on negative 2, so there's negative 2. I can go plot my directrix since it's a straight line upwards. There's my directrix there. I can also find, I can double my a value and go up. So here will be 4, and then I can do the same down here, so this will become negative 4. And I can put those points in there. And I already know that it's going to go through the origin, so I just need to link up. And if I actually sketch this nicely, you would find that this is a very nice peak of x squared. It's just turned on its side and has this weird. So this line here, this parabola, is all of our points of P. And again, the general formula. And always remember to label the equation. There's our equation there. And we've successfully solved this parabola. We can say that there's our focus there at 2, 0. We can say that we have the directrix at x equals negative 2. We have accurately drawn our parabola. And like all of the other Locus videos, I'll leave a link to a Desmos graph, and you can see the example here. And you can just drag these 2 points here to change the a value, and you can see how this affects the graph. You can also drag the focus around and play around with positioning, but that'll be in a separate video. But that'll be in the next video. So that's all the time that I have for today. If you have any questions, feel free to contact me on social media or leave a comment in the comment section below. And I will see you in the next video.